Hi guys, welcome to Piece of Code and welcome to this video. In this video we're going to learn about Docker on AWS. Okay, so we're going to see all of the things that you need to understand Docker on AWS. And also we are going to do a very interesting project where I'm going to create a microservice and deploy it as a Docker container on ECS. So stay tuned to it, right? So let us start with some basics of Docker and ECS on AWS. Let us see and let us understand it before going into the project. So getting started with Docker. So this is how the normal Docker flow happens, right? So you have an app, for example, you have a jar file and you create a Docker file for that jar where you specify all of the configurations and like the working directory, the commands to run that particular jar file or something like that. You will keep a Docker file where you will just write down all of those configurations, right, of that Docker container, and then you build a Docker image, right? Basically a Docker image is just a replica of your application which will be used to run the Docker container, right? And then you just push your Docker image to a Docker repository or a Docker repo, and we have a lot of common Docker repositories like Docker Hub, which is from Docker, and also there is Amazon ECR, which is Elastic Container Registry. We're going to see that later on. And then your Docker container services, right, like ECS or Kubernetes, right, they can pull that image from those Docker repositories and they can run that image. And obviously there are certain configurations that you need to do while creating that Kubernetes cluster or Elastic Container Service cluster, but nevertheless this is the typical flow. You create a Docker file, build a Docker image, push the Docker image to a repository, into a remote repository, and then using that image of the remote repository you pull it into a container service and then you run it on that container service. That's it. So this is the typical flow. Now let us see what are the Docker containers management on AWS. Makes sense. So we have the most important one, which is ECS, which is Elastic Container Service. It's Amazon ECS. It's Amazon's own container platform, right? It's Amazon's own kind of proprietary container service, and it is a very easy to use and understand. Then we have Elastic Kubernetes Service, which is EKS. It is Amazon's managed Kubernetes. Like you can also create a Kubernetes cluster. You can also create it on your local machine to run Docker containers, or you can create it in your own data center. So if you already have a Docker Docker containers running on your Kubernetes cluster and you don't want to use ECS, because see, if you have a Kubernetes cluster and you want to migrate into ECS, then there are some of the configurations are different, so you need to kind of reevaluate your logics a little bit. So if you don't want to do that and you want to stick with the Kubernetes thing, so you can use Amazon's EKS, which is Elastic Kubernetes Service, and remember that it is open source, right? So basically a lot of cloud providers provide these Kubernetes service. Like in GCP we have GKE, which is Google Kubernetes Engine, and likewise in AWS we have Amazon EKS, which is Elastic Kubernetes Service. So if you already have a Kubernetes cluster running in your data center, you can just migrate it over here. It's just for free. Obviously you're going to pay for the resources. This migration is free, so don't take it the wrong way, right? Then we have AWS Fargate. So this is serverless container platform. It means that even though you are running a ECS cluster, right, Elastic Container Service cluster, the underlying resources are EC2 instances. That is not a thing, right? Those are EC2 instances only. That is not a new thing to understand, because whatever compute you are using on AWS, those are EC2 instances. But Fargate is a serverless medium of creating your clusters. It means that you don't have to worry about those EC2 instances, underlying EC2 instances. You just create the cluster and just let ECS take care of the scaling up and scaling down. That's about Fargate. And it works both with ECS and EKS. And then we have ECR, which is Docker repository. Okay, let's move on. Talk about Amazon ECS, you already know that it is a elastic container service. But the thing is, there are launch types in ECS, and as you have guessed, one of the launch type is Fargate, which is a serverless type, and another one is the EC2 launch type, where you basically have control over your EC2 instances, like how they scale up, how they scale down, in which auto scaling groups are your EC2 instances in. You have to take care of all those things, right? And you must provision and maintain the infrastructure. As I've told you, you have to take care of everything. Okay, so this is about EC2 launch type, where your manual intervention is necessary and you need to keep your instances running. It is your job. Okay, so if a new Docker container comes in, it will run in any of the EC2 instances that you have created, and these EC2 instances will be in a ASG or auto scaling group. Okay, makes sense. Let us move forward. Now, talking about the Fargate launch type, right? As I've already explained, launch Docker containers on AWS. You do not provision the infrastructure. As I've told you, don't have to worry about all those nitty-gritty things. You can just create the cluster and just say voila, that's it. It's all serverless. You just create the task definition. Now we are going to dig deeper into task definitions in just a minute, so don't worry about it. It just means that you just worry about your Docker containers, don't worry about the underlying resources. AWS just runs the ECS task for you based on the CPU RAM you need, that's it. And to scale up and scale down, just increase the number of tasks. Fargate will take care of everything else. Now, what are tasks and what are task definition and what is a service? Because before working on ECS, you need to understand what each of these terms really mean. Very, very important to understand. Now let us start with the very small thing, which is the ECS task definition. So as the name suggests, it is the definition of your task. It means that it will contain all of those configurations that you need for your containers to run. For example, the port details, right? The image details, where it will pull the image from the repository, the volume and storage. So you can compare this task definition to the EC2 creation console, where we specify what are the RAM we need, what is the instance type we need, and everything, right? So the task definition is just some information about the task that you are about to run, right? So task definition is just information about the task that you want to run. Now talking about tasks, so you can run multiple tasks using one task definition. It means that you have imported one. You can, for example, what is called Nginx, image into a task definition. You have specified this image URL in the task definition as the image for your container. So you can run multiple containers or tasks based on that particular Nginx task definition. Like you can run, so there is a task definition for Nginx, and you can run task 1, task 2, task 3, or n number of tasks under the task definition. So you can just compare tasks to containers, right? So a Docker image will be running inside a container inside a task. So that's all it means. So don't get confused about it. You create a task definition and then you create a task. Now what is a ECS service? Now whenever you are creating a task, it is going to run containers, right? Your Docker images. And sometimes what happens is that, not actually sometimes, like most of the times, like 90% of the times, your task needs to run continuously, right? So you started the task and it is for example a web server, like for example a REST API, and obviously your clients are going to be communicating with your REST API, right? So that task needs to be run 24/7. But sometimes what happens, due to some kind of a bug or some kind of other stuff happened, maybe I don't know, Superman came in or something like that, your task goes down. So the ECS service will be responsible to spin up a new task in the place of that. And still I don't understand why I gave that Superman example, because I like Superman, whatever. So the thing is, your ECS service is going to manage your ECS tasks. and your ECS task definition will be providing the information about the ECS task. Okay, that is clear, I think. Now talking about this ECS cluster, I think it is very easy to understand now that ECS cluster is actually those EC2 instances or that Fargate cluster that you are going to create, and inside which your images are going to be run as containers, right? So that is a ECS cluster, nothing but a collection or a set of EC2 instances or Fargate clusters, right? Then upon that is the ECS, which is Elastic Container Service. That's it. So this is all you need to understand before creating or working with ECS. I think this is very much of clear now that how will you work with ECS, right? So talking about roles in ECS, why do we need roles, right? Now, for example, there is a task 1 T1 task running, right? And you have some container which is running over there, and this is a standalone task, so it is running on its own, so it makes no sense that it needs a role. But for example, let us consider that there is a RDS instance or a relational database service also running over there, and this task 1 needs to fetch some data from a database, right? So it needs to access the RDS instance, obviously the database it needs to access. Now how will your task 1 access the RDS database if it doesn't have a role associated with it, which gives it permissions to access RDS? So that is what you mean by a ECS task role, right? Your ECS tasks may or may not access certain AWS services, right? And if they are accessing that AWS services, then you need that role to access that service. That is a ECS task role. Now talking about EC2 instance profile role or ECS instance profile role, this is a different kind of a role. So when you are going to start a service, or when you are creating a task definition, it needs to pull the image from a certain repository. If it is pulling from ECR, then your ECS agent needs to have a role to access ECR, because your tasks do not need access to ECR. Your tasks are just going to be run according to the task definition. So just keep that out of it. Don't say questions like your ECS task is pulling the image, so we need to associate that ECR role into our ECS task. No, not like that, because your ECS tasks are independent containers running in a running your Docker images. So they just need the roles to access certain services like RDS or S3 or something like that. But the actual the role, that is ECS instance profile role, is actually assigned to the ECS agent to make API calls to the ECS service, or to send logs to CloudWatch logs, or pull Docker image from ECR. So that is an example about EC2 instance profile role, and it is being given to the EC2 instance, underlying EC2 instance, and it is being managed by the ECS agent over here. So that is the difference between ECS task role and instance profile. So I hope that makes some sense right now. Now talking about Amazon ECR, and it is Elastic Container Registry. So it is used to store and maintain Docker images. It is fully integrated with ECS, backed by Amazon S3. So basically it means that whatever images you are storing into Amazon ECR, it is actually getting stored on S3, right? And it also supports image vulnerability scanning, versioning, image tags, and image lifecycle. So you can do a lot of stuff regarding security, scanning, vulnerability, and all those stuff on ECR. Okay, so before discussing anything else, let us now start with the project. Okay, so let us understand the project right now. So I'm going to create a microservice, a very simple microservice I'm going to create, and basically it will be a Spring Boot microservice, right? And then what I'm going to do is basically I'm going to create an image of it, right? Create Docker image, and then what I'm going to do is I'm going to push that image into ECR, push image into ECR, and then what we are going to do, we are going to pull that image into ECS and run that image on ECS, run the image on ECS, right? So this is the project that we are going to do, and let's get on to it. Let's start with the project. So let us start our project by creating a simple Spring Boot microservice. So let me navigate to start.spring.io, and here we will first create our base Spring Boot project. It's very simple. I'm not going to dig into the details because you can create your microservice using any language, right? I'm using Java. You can create using Node.js, Express.js, or even Python. I mean, only the Docker thing is common. Otherwise, you can create a microservice using any language, right? So I'll choose Maven over here, and I'm going to choose the Spring Boot as 3.0.5, and let us give the group as piece of code, and artifact name or the project name as Docker API, or Docker example microservice, something like that, and Spring Boot Docker, and let us give it like Docker microservice. Okay, so the package name is this thing. All right, the packaging is jar Java 17, and remember one thing, if you are using Spring Boot version 3 above 3, it only supports Java 17, so you cannot select previous versions of Java for this. Add dependencies. I just need my web dependency for creating the REST APIs, and let us also take the Lombok dependency for reducing the boilerplate code. I think that should be it for now. We're not going to use any database and stuff, so that should be it. So let's create generate, and if we need, for example, any other microservice, then any other dependency, then we'll add it manually. All right, just copy this from here. Let me go to my Spring Boot projects folder. Okay, and let us just paste it, and let us extract this thing, extract with here and paste it. Okay, let us delete this thing. Okay, now let me just close everything. Let me go to my IntelliJ IDEA, and let us import the project, right? So new project. Okay, you know what, let us open a project, and it should be here somewhere, Docker demo. Not this one, it was something else, Docker example microservice. Yes, this one, trust project, and here we are. So this is the project setup. Now I thought of doing this project setup while I'm recording, because if someone wants to follow along, this can be also a very good refresher for someone who is learning Java development, right, backend development using Spring Boot and everything. Okay, so over here I'm going to create a couple of packages first. Let us create the controller package for for the controller classes. Then let us create a package for service, and one small package, or no, why small, the same small, for DTO class, right? So for the data transfer classes, so DTO. Okay, so let us go inside our service class, and what, let's first design our API. Like, let us first understand what API we are going to make. So I'm going to create a Java class over here, and I'm just going to say employee controller. So we're going to create a simple API where what will happen is that let me just remove this thing. So for example, the endpoint will be something like /API/users and then /1. So it will pass this as a path variable, and based on this user ID we are going to return the details of the user as JSON, right? That's what I'm planning to do. So let us go over here and let us create it. Okay, so first of all we need to annotate it with rest control @rest controller, so that your controller, you can create REST APIs now over here. And let us also use the request mapping annotation. And basically, if you have a base URL you want to specify, you can specify it one place using the request mapping, and you don't have to specify at all of your get or post requests, right? I can just say /API/users, and you can omit this over here. It is not mandatory to give it. Over here, let me just go here and let us just create a get mapping function, and I'm just going to say it is going to return something. For example, response entity, and it is going to return user DTO. So basically we are going to create a Pojo class, user DTO class, and in that class we will structure like what we are going to return. For example, the first name, last name, email ID, and some stuff about the user, some details about the user. So let us quickly go into our DTO class and create this user DTO class, right? So otherwise this error will not go. Let us create the class user DTO, and let us specify the details over here. So private int ID, private string name, and private string email, and let us also say private string department. That will make sense a little bit. And we'll just use our Lombok annotations to create our getters and setters. So we can just use @data annotation, so that it will automatically create everything, getters and setters and everything. All right, let us go back over here, and it says to enter. You can just hit Alt plus enter and import class, and that should do the job. Now what we are going to say, okay, we are specified the get mapping, and then a response entity is used to return the data along with a response code. For example, you want to return 200 or 201, you can also do that along with the data. So let us give this method a name like get this is employee, right? Okay, get user or something like that, or get employee, you can just say. You know what, let us change it to employees. Should make a little bit more sense. Okay, get employee, and we will receive a ID, right? And the ID is int. Let us make it long ID. Maybe it makes sense to keep the ID as long. We can just say long ID over here, and for now just return null, right? We are going to fix this later on. So this long ID is coming as a path parameter, so we're just going to say @path variable, and basically what name we are going to give to the path variable, right? We are going to say, for example, employee -id, and we are going to map this name to this ID. So to do that, we are going to just say over here employee -id. Makes sense. So now let us create the functionality for this thing, right? Now let us go back to our user DTO, in our service, and create a new interface over here, because that's how we use in Java. So let us create a Java class, select interface, and let us name it as employee service. So this is the interface, and you know what, let us rename this to employee DTO actually. Refactor, rename. So it makes sense, right? Because this is not a user, this is an employee. So here it changed back to employee DTO. That's great. So let us go to employee service and create a method over here, and let us name the method as employee. We are going to return an employee DTO, and we are going to say get employee, and we are going to just say long ID over here. We're going to pass the ID. So that's it. And now let us create the implementation for this DTO. So new package, let us name it as IMPL, and inside of here let us create a new class, and let us name it as, for example, employee service IMPL, and let us implement employee service. So it says that we need to implement its methods now. So let us just hover over here and click on implement methods. It will auto generate the methods. Great, cool, makes sense. Now here what I'm going to do is I'm going to use some static data, and we are going to create some dummy employees, and then we are going to just put it in an array list, and then we are just going to return them back. Okay, yeah, let's do that. So alright, let us create that dummy data list. Let me just say list, and let us say employee DTO, and let us say employee data equals to new, we can just say array list, right? And over here let us put some data inside of it, right? You know what, let us create a constructor, and we can put it inside of that employee. Okay, now just remove it, don't need it over here. You can just say this thing, you can just say this thing, employee data equals to new array list, and that should be it. And over here we can just say what, we can just insert the data over here, right? So we can just say employee data. Let us create a bunch of employee DTOs first. So employee DTO DTO1 equals to new employee DTO, and it doesn't have all args constructor, so whatever. So DTO1 dot set ID1, DTO1 dot set ID2. This is okay, this was long. So DTO1 dot no, this is not set ID, set name, and let us name it as, for example, and DTO dot set something like set email, and let us say ast@gmail.com, and I think there is one more department, right? No, set email, and there is one more, that is department, and let us say IT. Okay, now let us just copy it one more time and just change some values, and we are good to go. Employee DTO2, and let us just copy this, copy, this is 2, this is, for example, something like that. Let us keep this as operations. Right, now just let us insert that into the employee data dot add, and here let us just say DTO1 and employee data dot add DTO2. All right, so we are done. Now we are going to do is search that particular employee data list using this ID, and it's pretty simple. I'm going to do it in one line by just using some stream operations. We're just going to say employee data dot stream, and then we are going to filter. We are going to get an employee, and we are going to just say employee dot ID, or get ID, sorry, is equals to ID that we are getting from there, and then we're just going to say dot, we're just going to say find any, and then we are going to, it will return optional, so we're just going to say dot get. That's it. This thing, if you are having problems understanding this, then it's a very good thing to use for loop or if conditions if you have any problems with this thing. But to keep it short and simple, I just did it like this, right? Now let us go back to our employee controller. and we are just going to do is, what we are going to do is just return response entity dot OK, and the body is just what? Okay, before that we need to first inject the dependency of employee service in the employee controller. I'm just going to say private what is that, employee service, and we are going to use constructor based dependency, so we can just say dot all args constructor, and we do not have to use auto wired because after Spring 5 if your class has only one parameterized constructor, then you do not need to use auto wired anymore, right? So we can just going to say employee service dot get employee, and just going to pass the ID over there. So this should work. Hope that it works. Let us start our Spring Boot service by going to Docker example application and run this thing. So we just enable annotation processing, and let me in the while just open up Postman, and I think we are good to go. We should start it. Okay, I forgot one thing though. It will be throwing an error. I knew it. Is that I forgot to mark this employee service simple as a service. So we need to do this, because if you do not mark this as a service, then Spring will not register this as a bean and it will not inject it in employee controller, right? Alright, so let us start our application and test our microservice. Okay, before starting it, actually I made a small mistake over here, so you can just ignore that. Just this, you don't have to provide with the brackets. Let us go to our Docker example application and run this. And I've also opened Postman, so let us type down the URL, which is http://localhost :8080/API/employees/2, for example, right? So it's up and running. Started Docker service application, and let us send this thing, and you can see that we are successfully getting a response for our thing. So ID2 is wiki, and this is the operations department. If we test it for 1, then it should just give me this one, right? So this working fine. So now let us see the next steps, which is now we are going to publish, I think, and then push our image into ECR and then run the image on ECS, right? Now let us do all that. Okay guys, so we were able to create our microservice and we were able to test our microservice. So if I just send this request with this path variable of 1, we are getting the correct employee according to that path variable, right? So this REST API is working correctly. So let us move on to the next steps, which is basically creating a Docker image and uploading it to a Docker repository, which is ECR, and then finally running it as a Docker container on ECS, on the container service, right? Now let us see the steps. So first of all, let me just select this project and let me go to Maven over here. We are going to create the jar file. We are going to build clean, and we are going to build and create the jar file for this, because the jar file is responsible to run at the Docker container, right? So let us move on and let us create the jar file over here. So let's go to lifecycle over here. Let us select clean and what is that, install, right? So just select these two things and let's just run it, right? So let's wait for a minute. It should create the jar file. Okay, so the build is success. Now if I just look in this target folder over here, so we have our jar file over here. Now let us move on and let us create the Dockerfile. Okay, so let us create the Dockerfile right now. Let me just right click over here and go to new, and let us create a file. Let me name it as Dockerfile, and cannot name it any other name like a bus or a banana or something like that, because it needs to be named as Dockerfile, otherwise it won't work. So I have a template Dockerfile which I'm just going to copy it from over here, and let us understand what all these commands mean. So first of all is the from. So basically the from means that, okay, what was this? Okay, so from means that you are creating this image, this current image that you are going to create. You are going to create it from a base image. In this case, the base image is OpenJDK 17 Alpine. So this is just an image of JDK 17, and this Alpine distribution is basically one of the most lightest images, right? Very small images, so you can use it for a lot of your Java based images, right? So that's why that's the from is for that. Then the volume is that if your Docker containers needs to store some data, like for a scratch file or something like that, then you can create a small temporary directory /tmp using the volume command over here. So you can store some stuff in there. Actually, you can omit it if you want. It's not mandatory to create this volume, so it's up to you. Next is the copy, and this is the very important, because what you are doing is you are copying from your source jar, which is in this case is present in the target folder, right? In this case it's the docker.jar, so I'm just going to replace it with the name, so that is docker example snapshot.jar to the Docker container. So by default, if you just leave it like this, it will just copy this jar to the root of your Docker container. But if you want it to copy this to another folder, if you want to create a separate folder, a working directory for your Docker container, you can just create a work dir /app or something like that, and you can copy this users microservice.jar to this /app directory. But let us omit it as of now. I don't want that. And also let's rename it to Docker example .jar. And this is also very important, because this basically runs the jar in the Docker container. Because if you see, this entry point command has the java -jar command, which is exactly the command which is used to run a jar file, a Java jar file. So what we are saying, java -jar, and just run this Docker example.jar. So in this case it is Docker example, so let us just copy it from here. So Docker example.jar, that's it. And what is this stuff over here? This is just for if your microservice supports encryption and stuff, then it is mandatory. Otherwise, in our case, it is not actually mandatory, so we can also remove it, but let us keep it in this case. But it's not mandatory. The only mandatory thing is java -jar and then your jar file, right? That's how we run the Docker container at the command line, right? So this is my Docker file, and it is ready. Let me just open it in the file explorer. So we're going to run some commands. Where is it? Let us find in files, analyze, refactor, bookmark, open in Explorer. Sometimes I'm so lazy and I'm so clumsy that I have problems with finding stuff. So I think that is Docker example microservice. So let us go inside of here, and let us go to the next step, which is basically sign into our console. And let's start with the fun stuff of creating the ECR repository, then the ECS, and then just deploy our Docker container in that. So I am in my AWS management console now. So what we are going to do is we are going to navigate to ECR. So this Elastic Container Registry. So we are going to store our Docker images there in this remote repository, which is ECR. So we're going to just go over there and let us create our repository first, right? So let's go to repositories and create the repository. You can either create your repository as a private repository or a public repository. It's up to you. I mean, it's up to you. So let us keep it as a private repository as of now. And the repository name, we can just keep it as, for example, Docker example MS or microservice. I think we should keep it all at defaults. You can include KMS encryption, so it will use a KMS key to encrypt your repository. For example, if I enable it, then you have to select a encryption settings and you have to create a KMS key, or otherwise it will use your AWS managed keys by default, but we don't want any of that. And there is a scan on push option, which is enable scan on push to have each image automatically scanned being pushed to the repository. Basically, it is vulnerability scanning. It means when you push an image into your repository, it will first scan for any kind of potential vulnerabilities, and it is very, very important if you are working with a production application, but it's not at all required as of now. Let's keep it all at default and let us create this repository. Okay, now it has been created. Select this repository and let us view the push commands. So here are all those commands. So let us run one by one all of these commands, and let us just work with it. Now these commands, it says that it works for Mac OS or Linux, but actually it will work with your Windows CMD also. But if you are working with PowerShell, then make sure you run all these commands, right? So before working with these commands, I need the user credentials, because I'm going to push my Docker repository using the AWS CLI, right? And to work with AWS CLI, you need to use AWS configure to actually log in as that user. And if you are confused about what is logging in as a user, then basically just refer to my IAM video, where I have discussed about access keys, secret access keys, and AWS CLI, how to log in into the CLI and all those stuff. Let us go to users over here, and this Akash user is actually the user with the admin permission. So basically it has all the permissions. So let us go to security credentials, and for access keys, I had already created an access key before, but the thing is I didn't store it, or did I? Let me just check it out in my downloads. I have the access keys, so I can use it. I don't have to create an access key anymore. That's good that I had stored it later previously. Okay, so let us go to our folder, which is, if I go back, this is the Docker example microservice, and we have the Dockerfile over here. So let us open our CMD over here. So here we are, and let us first run AWS configure. So it will ask for the access key. So let us copy it from here and paste it. Secret access key is this one. You know what? And then just keep all the defaults, and we are logged in. So now we are ready to run our Docker commands to push it into our remote repository. Let me just close this thing, and let me just move back to our Elastic Container repository, and let us view the push commands, and let us see what is actually it is doing. First of all, we need to retrieve authentication token and authenticate to your Docker client. It means that I need to use my credentials to authenticate with the ECR. That's why we have to run this AWS ECR get login password command. After doing this only, you will be able to push your images into ECR. Okay, so let us copy these commands, right? Let us first log in into the ECR, and then let us build all these things. Let me go back to my folder, and I have my CMD over here, and let us paste it. And I hope it will work well. So let us just, okay, it's taking some time. Okay, it's a TLS handshake timeout. Let us try it again. Sometimes it just happens to be an issue, but Okay, now you can see that the login has succeeded after 3 tries. So you can try it out. For me, I don't know why it timed out for the first 2 times, but the login has been succeeded. Yeah, great. Now let us go back from here and let us see the other commands. So the next one is the docker build command, right? And basically what it will do is it will build the docker image from the the Dockerfile, whatever commands you have provided, right? So let us copy this thing and let us paste it over here. Okay, it's not pasting. All right. Now here you need to provide your whatever your Docker image name that you want to give. In our case, let us keep it the same as our repository, which is docker-example-ms. So docker example-ms. Oh, it was the same thing. Oh, that is great. Oh, okay, it was the same thing. All right, now let us build it. So if you have any issues with your Docker file, or is there any commands which are not up to the mark, then it will throw an error over here. But if everything goes well, then the image will be created. And also if you run the docker images command now, then it should show you a image of that it was just created 15 seconds ago, and you can also check it in your Docker desktop, right? It's a visual way of managing your Docker containers and stuff. So our image has been completed. Let us see the other commands, view push commands. So the next step is to tag your image so that the push will push the image to the repository. So tagging is nothing but creating versions of your images. So for example, you updated your image right now, so you will assign a new tag to it, right? And basically this latest tag means that basically it is the latest version of your image, right? And basically you are tagging your image to the remote repository so that when it uploads, right, so the tag must match, otherwise there will be a issue. So this tag, that ms-:latest, should match with your remote repository, which is docker/docker-example-ms/latest. Otherwise, if there is a mismatch of tags, then it will be a problem. And it is actually true for any kind of repository, Docker repository that you use, like Docker Hub or something like that, right? Now let me go back over here and paste this thing. Okay, let me just paste it again, copy it again, and paste it over here. All right. So a small step, and the last step is nothing but to push that image into this newly created AWS repository. So we're going to use the docker push command and then the remote repository URL. That's it. So now you can see the push refers to repository, this thing, and this is the docker example-ms, and it should take some time. And it will take some time to push the image. So I'm going to pause my video right now, and then after it is done, we are going to move forward with the ECS one. Okay, so after trying a couple of times, it was, I don't know, it was just saying, TLS handshake timed out, even though my internet is fast. I don't know why it was happening. Sometimes it happens. So at the end, I was able to upload it to ECR, and you can see in ECR, we have this image right over here. So now the next step is to create the ECS cluster, and then we're going to create the task definition, and then we're going to run as service, right? That are the next steps. So let us go over here and let us search for ECS. And Elastic Container Service, let us just go there. Okay, I don't know why it is taking so much time to load, but it's fine. Alright, so let us now go to clusters and let us create a cluster right away, and let us give a cluster name, which is Now before going through this demo, guys, this demo is going to cost you a little bit, not that much, maybe 40 to 50 rupees. At the end of the month you are going to receive that as a bill. But if it is okay with you to spend a few bucks in this tutorial, then you can go ahead, or otherwise you can just sit back, enjoy and watch this tutorial with your coffee in hand. Yeah, just your coffee in hand. So the cluster name is, for example, let us give it as prod cluster, right? And you can select your own VPC. I had created previously my prod VPC, but still it has not been configured completely, so I'm not going to use that VPC, otherwise there will be issues. So I'm going to use my default VPC which comes in with your account, right? And you can also choose in which subnets you want to deploy. For now it is being deployed in 6 subnets, so let's keep it at that. And here the infrastructure, as we had discussed in our slides, you can either go for completely serverless like Fargate, or if you choose a combination of Fargate and EC2 instances, you need to give your autoscaling group, you need to create an autoscaling group, because the instances needs to scale in and scale out, right? So autoscaling group is required. You need to give the desired capacity and everything, but we are going to stick with the Fargate as of now. If you want to create your own ASG and all that stuff, you can refer to my ASG video. I have shown in detail how you can create your own autoscaling groups and stuff. So if you enable container insights, then basically CloudWatch will monitor your containers and you'll get insights about your container, like if there are any failed requests, or if there is a kind of a hacker or someone who is actually trying to access the IP address of your container or something like that continuously. You'll get all those insights and everything. So you can enable if you want. I don't want it. So let us just click on create. So it will take some time to create the cluster, and in the meanwhile let us go to our task definitions and create a new task definition, because it is independent of the clusters. So I had already created the cluster, so it should take some time to create it, maybe, I don't know. Let us create the task definition in the meanwhile, and let us create the task definition, and let us give the task definition family name as, for example, Docker example ms, right? So here you can specify, you can run multiple containers in a single task definition, as I've already told you, right? You can specify a container number 1 or container number 2. You can add more containers, right? And also you can run multiple multiple instances of your container also. So the task definition is just the details about your containers and stuff, right? So the first container, and I'm going to only have one container in my task definition, so I'm just going to specify that, and this one will be named as Docker example, something like that. And image URI, basically, as it is going to be in my ECR, so let us move back to our ECR and let us copy the URI from that place, my image URI. So let us just open it in a new tab and let us copy that URI. And this is the one, and we'll just go over here and image URI, let us copy the URI of this image, and let us just go back over here and let's just paste this one, so you can see the image URI is there. Other things are container port, and basically this is the port mappings, right? So basically at which port you want your application to run. For now let us give it 8080, the default port for Tomcat, so that it will map the application port with this container port, and app protocol is HTTP. You can also add environment variables. For example, your application.properties file, in my case I'm using Spring Boot, so for example my application properties file is taking some environment variables, so I can inject it over here directly by adding the key and value for my environment variables. And you can directly add an environment file which will have all the environment variables that you need, so that you don't have to add it continuously one by one, right? You can also add health checks, and there are also some Docker configurations which we are not interested in. So let us click on next. Oh, sorry, let us remove this. We don't want any environment variables. Okay, so app environment is Fargate. Let us keep it to that. Operating system is Linux. Task size, let us keep it to the least, so that will cost us a very less money. So let us keep the memory at 1 GB. That should be fine, right? Okay, so the task role, as we have already talked about, right, that if your service is accessing some other service, then basically it needs a new role for that. And basically if, for example, my microservice is accessing RDS, then I need to create a role which gives its permission to access RDS. But in my case, I don't have to access any other service, so let's keep it as none. And the task execution role is basically that profile instance role, right? Basically, it will communicate with ECR to create a new image, to pull the image from ECR and stuff. So we need the task execution role for that, and it will be used by the container agent, right? We have seen that in our PPTs and stuff. It will use API requests on your behalf, so it will create a new role for that, and it is absolutely mandatory to create a new role as a task execution role. Otherwise, it will not be able to pull images from the ECR, and also it will not be able to push the metrics to CloudWatch, and those are two fundamental things that you need in every application, right? So let us keep it as create a new role. Storage is optional. If you want, you can give some storage volumes, for example 10 GBs or something like that, but we're going to keep it at the minimum. And you can use log collection for a logging destination using default configuration, so let us keep it as that, or otherwise let us uncheck it. We don't want any collection as of now. I think that should be it. Let us go to next. So this is the thing, so you can review everything and you can create it. So I think it will take some time, like 1 to 2 minutes. Let us pause the video and let us continue after this task definition has been created and our cluster is being set up. Then we are ready to create our service, and then finally we are going to run our Docker container. Alright, so we have created our cluster and we have created our task definition, right? So now it is time to deploy our task definition as a task. So let us select this and let us go here, and you can either run it as a task, so it will be like once, or you can create a long running task or create a service, so it will be up 24/7. Let us create a service, choose a cluster, my cluster. Now if you remember, I had named my cluster as prod cluster before, but for some reason it didn't get created, so I just created another cluster which is my cluster. You can just follow along that tutorial only, and you can just name your cluster whatever you want. You can name your cluster as a dog cluster for all I care, right? It's up to you. Then here is the capacity storage provider strategy. You can actually use a set of Fargate and Fargate spot instances to reduce your cost or something like that, but let us go for the basic one, which is simply the launch type, and we are going to select Fargate. So I want the serverless infrastructure, so I'm going to go with Fargate. You can also go for external if you want to run your task as an external in some external resource, like on a data center or something like that. Actually, for that there is a feature called ECS Anywhere, which is if you want to run the instances on your own data center or your own computer, whatever, your own server. So application type is service, and the service name, let us give it as Docker example MS service, and desired number of tasks is 1. I want to only run one task. And when I talk about networking, let's choose the same thing as a default VPC and 6 subnets as of here. Let us create a new security group for this task, and let us name this security group as Docker example MSSG, and let us give the inbound rules for the security group. Now if you remember, we have mapped our port for 8080, right? So we can just say custom TCP, and port range is 8080, so we have to allow inbound rules on port 8080. But if you select TCP HTTP, then by default it will take 80 port range, right? So but we need is custom TCP, and the port is 8080. and the source is basically anywhere. Let's keep it anywhere, and that should be it. You can also go for load balancing, but we haven't created any load balancing. You can create an application load balancer for that, but the thing is, load balancer are especially helpful when there are a lot of tasks running, right? But we have only one task running, so it should be fine. About service autoscaling means that basically if your if you, for example, it is just scaling up and scaling down the tasks. If your load is more, then basically it will automatically scale up the tasks, increase the number of tasks, okay, and vice versa. If your load is down, then it will automatically decrease the number of tasks. But since we have only one task, so let us keep it simple, and let us click on create. Okay, so let's give the description over here, Docker example SG. Okay, let us create. It may take a few minutes, so let us pause the video and let me continue after it has been done. Alright guys, so waited a few minutes and finally our task is up and running, our service is running. So let us go to our clusters, and let me go inside my cluster. So let us go to tasks. So this is the task. Click on the task, and if you see, here are the details, right? Here are the memory configurations that we did. The launch type is Fargate, task definition, and here are all the networking details. So we'll just copy our public this public IP, and I'm going to open Postman again, because we had one API, right, that was fetching the user based on that particular ID. So we had created a simple REST API for that. Let us try that out now. So here, instead of localhost, I'm just going to replace this with the public IP address of my container or my task, right? And let us click on send. All right, so you can see that now instead of fetching from my localhost is, I think, is not running at all. So I'm not messing with you. So basically what is happening over here is we are using the IP address of our task, and we are fetching the data. If I click on 2, then it should give me another user for it. So we can see that we are able to finally deploy our Docker container as a ECS task by creating a cluster, then creating a task definition, and creating a service. So I hope you guys got an idea of how to create all these things. And one thing very important to remember, after you are done with everything, you should delete the cluster, right? So basically just select this and delete the service, force delete service, so that you will not get any charges. Obviously it will be, some charges will be levied because we had created something. Regarding the task also, just it will automatically get deleted, so no issues over there. And finally just delete the cluster, delete my cluster. Okay, so after the cleaning up and stuff, you should be good, and you can just delete the task definition also. And the task definition we should be able to delete, but I can't find it over here. Okay, I'll delete it later, no issues. So alright, let us go back to our slides over here, and let us discuss one or two things that are remaining. Alright, so let us see about ELB integration. So it means that you will be easily able to integrate application load balancer with your ECS cluster. So basically your application load balancer will sit above your cluster, and the requests coming to your application load balancer will be automatically redirected to the particular ECS task. So that's all what about the application load balancer integration. It's very easy to integrate the application load balancer. Instead of the target group, you need to specify your ECS task, your ECS cluster. That's all you need to do. And let us go forward and talking about ECS scaling. Now in here you need to understand two things. One is ECS service autoscaling, which we saw as an option over in your ECS while we are creating the ECS cluster. Now the ECS service autoscaling is different from autoscaling group autoscaling. Now what I mean by that is, if you enable ECS service autoscaling, then basically your tasks will be autoscaled. So if there are limited number of tasks and you need to include one more task, then one more task will get created. But the underlying EC2 instances, right, they will not be created again, because that is not autoscaling group autoscaling. This is just task autoscaling. So now how will you enable your underlying EC2 instances to scale automatically? For that, you need to enable ECS capacity providers. We saw that option, right, and it was optional. Now what will happen? You will create a CloudWatch metric, which is ECS service CPU usage. It will trigger a cloud alarm, and then it will scale your autoscaling group automatically. But you need to configure ECS capacity providers before enabling this option, because all the while we were creating our service, there was an option of enabling ECS capacity providers, and there it was an option to for Fargate or EC2. So you need to enable this thing, right? So one thing you need to keep in mind is that the service autoscaling is different from your EC2 autoscaling. Even if you enable service autoscaling, it doesn't mean that your underlying EC2 instances will also scale up. For that, you need to enable that in ECS capacity providers autoscaling, right? And using the combination of these two, your service autoscaling and capacity providers along with your CloudWatch alarm, you will be able to create a dynamic ECS cluster where your underlying EC2 instances as well as your tasks will be able to autoscale. Now there is a catch in that. If you go for Fargate launch type or stuff like that, then basically what will happen is that you don't have to enable this thing. Fargate will take care of all the underlying stuff. You just have to enable ECS service autoscaling, right? So you need to keep all these things in your mind, and then you're good to go. So yeah, that's all about Dockers, guys. I hope you like this video, because I tried to show you as much as I can using a lot of examples and a hands-on demo and something like that. So yeah, that's it from my side for this particular lecture. Let us meet in our next lecture. Till then, have a nice day. Bye bye.